Alright, I just wanted to put together a short tutorial on some of the new features in Sidewinder. As usual, to update Sidewinder, simply go to Help and select Check for Updates. And when you click the next button, Sidewinder will go out and search for a new update. In this case, I was running version 437, and it's telling me version 444 is available and list all the new features. So with that, in version 447, what's new? Starting with motor inertia, we've actually updated the lookup table for smaller motors, 50 kilowatts and below. The inertia, the motor estimate, is a bit more accurate now. Also, with the dynamics, we've added this tab to include. It's up to the user to include or not include the motor inertia for the starting calculations. So, for example, say we've got a direct on line here with 220% starting torque. In that case, with the checkbox checked, it includes the motor inertia in the acceleration calculations, the way Sidewinder previously did it. However, if we click a fluid coupling, see, motor inertia is not included in the starting calculations. This is also the way it previously was. If you had a fluid coupling, it just behind the scenes didn't include the motor inertia, because obviously with fluid coupling, the motor comes up to speed before it starts transmitting torque through the coupling. You could say, all right, there may be some torque transmitted, but for the most part, it comes up to speed and then starts transmitting the torque. But we've now explicitly added that, so it's up to the user whether you want to include or not include. By default, it's included. However, if you pick any of the fluid coupling types, by default it will not be included for the fluid coupling types. If you pick say a squirrel cage, it will be included. However, like I say, if you want to change that, you can go ahead and change that. Other things, the vertical profile, as far as the ground line, is kind of a minor thing, but I can see it being useful. Previously, if you had an AutoCAD file, I just drew this up here quick for this example, but the ground line always had to start at 0, 0. You don't need to do that anymore, which is just sort of nice. If I go ahead and import that ground line, you can see it just doesn't have to start at 0, 0, and we just kind of cleaned up some other things with importing that as well. Other items, SEW for reducers. We always had the Falcon, the Flunder. We added the SEW. Essentially, that's based off of the MC series catalog from the Euro drives, and essentially that catalog, the MC R3s 2 through 9, I believe is a series. For example, this one, if we look, this particular conveyor, yeah, it says 13.54. The actual catalog reducer ratio is 14.76. So it's kind of nice actually having the real frame size and just quickly being able to look up the reducer ratio. Totally open if there's other reducers besides the MC3 series here that you guys would like to see added. Just let me know. Send me over some details. Happy to add other reducers as well if you want. Just send me the information. It's easy to add for us. Structures, structural loads. This is a biggie. Actually, there's a whole separate tutorial on this, tutorial 25 I believe it is, so I'll just let you review that tutorial, but we've added a whole thing for structural loads. One note that we did actually add after I had made that tutorial was on the structural tensions. We've added, if you scroll over here, the bearing reactions. So the X and Y bearing reactions at each pulley for the max tensions, for the min structural tensions, and for the FLN case. And let's see if I just move this over here and expand this out. You can see those. Well, anyway, you can see all of those if you maximize your window. I'm just running a small screen here, so those are all there. That's also all in the report, which is quite nice. If you go over to the report, by the way, Office 2010 is now supported as well. So if you're running Windows or Office 2010, Word 2010, Sidewinder now supports that. If you select the structural, in this case I've selected the pulley and the structural loads. If I go ahead and just look at that file, you can see for the structure, if I go down to the structure stuff down here, well, first for the pulleys, we've added just this nice little page if you add the pulley details that just shows a little image of all your pulleys in the conveyor, which is just kind of nice having all of those on one sheet. For the structural loads, somewhat the same as what we had before, but we've also included again the bearing reactions, and the entry angle and exit angle of all the pulleys and so on and so forth, the flooded belt information and a picture of it and that sort of thing. So just added some more details on that. Like I say, take a look at that structural tutorial. Let's see what's next. IP, moving IP points. Yes. In the vertical profile, again, there's also a whole tutorial on this as well, but you can now actually click on different elements. If I want to move a pulley, like for example, if I want to move this pulley, I can actually click right on, click and hold. I'm just left clicking, and I can move that pulley around, which is kind of nice. If I actually want to just move the incoming flight, this flight here, I can click on the incoming point and move the whole element around. So that's something new that I think you guys will find useful. Design summary in the multiple conveyor projects. This is something that we've added. I'm just going to grab a couple files here. In the multiple conveyor summary, obviously you see we've added the picture here, which is quite nice, and we've also just cleaned this up a bit. You can really copy and paste this in Excel. Now it copies a bit nicer. We've added some new inputs in here, so on and so forth, so clean that up a little bit. L10 lives bearing calculations. If we go to the L10 bearing calculations, again we've just added a bit more detail, so you can specifically, if you're really interested in seeing how we calculate the L10 lives and whatnot, all that information is really clear now. For example, material load, and I'll just step through this one for you guys to just show how this is calculated. If we look at this specific conveyor and I say, alright, my material mass happens to be, what, 69.3. I'm just going to type that in. My idler spacing on this conveyor is 3, so 69.3 times 3 is 207. Multiply that by gravity, 9.81 gives me 2039 newtons. Okay, so I've got 2039. So why do I have 762? Well, if we look at the roll, essentially what this is saying is for that material, 74% is over the center roll, whereas 12.6 is over each of the wings. So if I take my 2039 that I had, multiply that by 0.747, I get 1523. Okay, still not 762. Why? Well, because this is for each bearing. Well, the center roll, each bearing takes equal, so we multiply that by 0.5. Hey, 761.8. 762. There we go. For the wing rolls, obviously the wing roll, the outer bearing takes less load than the inner bearing. For this specific layout, the inner bearing's taking 82%. So we'd take our original value, the material mass times the idler spacing times 9.81 times 12% for the wing roll times 0.82, and you get the bearing. So that's the material load, vertical load factor. With the lumps, that's essentially this lump dynamic material factor. Right here, again, you can read and look at the details, but that's a CO factor times the velocity squared, so on and so forth. So that's the material. You can do the same for the belt, vertical curves, installation tolerance, all that sort of stuff. And the bottom line is we end up with a vertical load, and we also have a horizontal load. So that's a vertical and horizontal. Well, due to the angle of the idler, the center roll, obviously we need to convert those to a radial and an axial force for the bearing. In this case, we have, this is our vertical, that's a horizontal. If we just do that vector conversion for our wing, there's our radial and axial force. And now to get the equivalent bearing load, that's where you need to look in the SKF catalog, and you can take a radial and an axial load. You can look up these x0 and y0 factors, and you combine those together. There's an equation in there. It's in the manual as well, and that gives you your equivalent bearing load. That's what's then used for the L10 bearing calculations. So a lot of this was already in there before. We've just added some additional information. So if you really want to, like I say, by hand sit down and calculate that out, this is exactly how it's done. It's very, very open. We've tried to make the code very, very open so you can see where all the numbers come from. Preferences. On the preferences page, there's a slew of new items we've basically just added here, and you can pretty much, these are all pretty self-explanatory. Allowable sag and default materials, a bearing turn down, what's allowable bearing turn down, your default pulley, ceramic and rubber friction factor, so on and so forth. Idler for the L10 life. Again, we slightly changed this. Our miscellaneous reduction factor used to be 1.15. We've actually changed that to 1.1, and the default installation tolerance is 2.5 millimeters. Again, you can go in here and now set these up however you'd like. So it just gives you a bit more flexibility on the user preferences. Back on the pulleys, we've actually added a few different material types. These three are some new material types we've added. The bearing centers, we just added that as well. Simply, you can enter the bearing center if this value, and if we look at the tool tips here, if this value is less than 60% of the belt width, in other words, say if I enter 400 here, I've got a 1,000 millimeter wide belt, it takes this as an addition to the belt width. So that's kind of nice too for your pulleys. You can say just make them, all whatever, 400 millimeters or 300, whatever it is, over your belt width. Some people prefer to enter it that way. So I think that pretty much wraps up some of the main items. Like I said, there's a couple other videos you can certainly take a look at, and if you have any questions, give us a call, let us know. Take care.